Okay, section 2.3 is the sine law. And in previous courses, you could solve right triangles using sine, cos, and tan. So as long as you had two pieces of information plus the fact that it was a right triangle, okay, other than all three angles, of course, because then that could be similar triangles. But if you knew at least one side, you knew it was a right triangle, and you knew another side or an angle, you could always solve the triangle and know what all the sides and angles were. But you could only do that for right triangles. Okay, so you, if you had a triangle that didn't have a right triangle in it, you kind of didn't really know what to do. Okay, so we're going to learn to solve any triangle as long as we have three pieces of information, and it can't be all three angles. You have to have at least one side, and then you'll be able to solve it. Okay, so the one useful formula is the sine law. Okay, and it can be written as side A over the sine of angle A equals side B over the sine of angle B. Okay, C over sine C. And for each of those, you just have to have, you always know that, I'm not going to make that into a right triangle. I don't want it to look like it has to be one. But you're always going to have the angle and the side opposite. They're going to have the same letter, right? So this is angle B. It's going to be side B, etc. Okay, and it doesn't have to be a right angle to use this one. That's the difference between this and what we had before. You can, when you use it, you can take any two of the ratios. Okay, so you might set up an equation using A and B. Okay, or you might set up an equation using B and C, or you might set A, this part, equal to this part. Okay, any two ratios. Another thing you can do is you can use it upside down too, which is useful if it's your angle that's your unknown. Okay, you can write whichever two ratios you choose to use. You can write it like that as well. Okay, same thing. All right, and it's a pretty easy formula to derive. Okay, you can do it by taking that angle or that triangle, and I'm going to deliberately not draw a right angle. Okay, and so let's make this A, B, and C. Okay, you know what I should have done actually? I'm just going to take my triangle. That makes a straight line. I just want that to be a horizontal line on the bottom, just for ease of my derivation of my formula. Okay, just pretend that this is horizontal. Okay, pretend that AC is horizontal. Okay, so let's imagine that we want to figure something out. We only know sine and cosine for right triangles, sine, cosine, and tan, but that's okay because I'm just going to draw the altitude. You know what an altitude is for a triangle? It's when you take a line segment from your angle straight down at a right angle to its opposite side. Okay, and you can draw three altitudes on a triangle, and sometimes they're outside the triangle, but that's okay. And what I'm going to do is I'm just going to call that side H. Okay, and so we'll just see that we're going to be able to figure out things about this triangle. Let's start with, let's take the sine of angle A. Okay, and that's going to be equal to its opposite over the hypotenuse of the right triangle that we just made right here. Okay, and we can do the same thing with C, right? You can see that sine C is going to equal its opposite, which is H, over its hypotenuse, which is small a, right? And so if you wanted to multiply both sides of this one by C, okay, you would get C sine A is equal to H, okay, and over here you'd have A sine C is equal to H, okay, and since that H is the same for both of them, we can substitute, we can use the transitive property here, okay, C sine A equals A sine C, okay, and so then if you wanted it to look like the equation that we have there, divide both sides by sine C and by sine A. Okay, that's going to cause this to cancel here. You end up with A over sine A over here, and you end up with C over sine C over here. Okay, and you can easily do that exact same thing to find B or to find C. Okay, so it's a really actually quite an easy formula to derive. Okay, and it makes a lot of sense. I'll just show you why this actually works also. This really leads well into the other part, but is this going to work also if you have an altitude that's going to be outside the triangle. Okay, so I'm just going to do A, B, and C. Okay, now when I draw that altitude, it's out here, right? So it's going to join up. We have to extend our base just to show what the altitude has to be a right angle to. But yeah, our H is going to be over here. Okay, this is small c, this is small a, and this is b. Okay, and so it's a little bit different. Well, let's just see what we get here. Okay, we're going to start by taking sine a. And in this triangle with h, we want to do the opposite over the hypotenuse, and that's going to be h over small c, right? Okay. With c, we have a bit of an issue here because this is angle c, right? Okay. So can we really say sine c equals h over small a? That's a. Okay. And the reason that we can say that is because any angle, the sine of any angle is equal to the sine of its supplement. Okay. Right? 180 minus that angle. And you know what? We learned that in the last section. Okay. Because we saw that if you have your xy plane, okay, and we know all soup turns cold, okay, we can see that this angle and this angle, okay, this would be theta, okay, this would be the reference angle, which is the same, but that the actual measure of that angle is 180 minus theta, okay, and so you can see that the supplement of this angle will have the same sign, okay, because they have the same y value, okay, and they have the same r value, okay, and the only thing that's different is that the x would be negative. So they are not going to have the same cos, but because sine is y over r, you're going to have the same value for those, okay. So what that means is that sine c, okay, sine c in the triangle is actually going to be equal to the sine of, let's make this x or something, it's also going to be equal to the sine of that angle. Okay, and so since we're using, basically we're using sine, we're using the triangle, and we're saying sine of angle BCX, which is not the same as our C in our triangle, is equal to h over a, but we've also shown that sine BCA is going to have to equal the same thing just because of this, right? All right. So taking that back and just ignoring that whole extra triangle that we had, we can just say, for our formula's sake, that sine c is going to be equal to h over a. Okay, and that's going to allow us exactly the same formula that we have here. So I just wanted to show you that. That'll go together the same way we did when we were making that. Okay, so I just wanted to show you why that also works for if you had your altitude outside the triangle. Okay, so if your angle C was obtuse, also works. Okay, and that's really important because you don't want to think when you look at another triangle, is this going to work for this? And the other thing is that's going to cause problems, and we'll see that in a second. So I'm just going to split this lesson into 2 videos so it doesn't get too long. This is deriving the sine law, and the next one will be the ambiguous case.